Let's find the tangent plane approximation of z equals x squared y near the point 2, 1, 4. Well, the first thing I'm going to be looking for is a partials. So let's take a look at the partial with respect to x. And that's going to be 2xy evaluated at 2, 1. That's going to give me 4. Now the partial with respect to y will be simply x squared evaluated at 2, 1. That's also 4. So now well, actually, before I come up with the equation of the plane, let's take a look at this in terms of differentiability. Notice that the partial with respect to x and the partial with respect to y are defined everywhere. So clearly they're defined near this point. So it's not an issue. The tangent line approximation should be just fine because I don't have to worry about any discontinuities. The equation of the tangent plane is then, well, let's do a couple different ways. Let's start off with z minus z naught equals the partial of x times x minus x naught plus the partial with respect to y of y minus y naught. Substituting these values, I will get z minus, where's z? There, 4 equals 4 times x minus 2 plus 4 times y minus 1. So z equals, 4x minus 8 plus 4y minus 4 plus 4. Move this z over. That's going to go away. So I'm just going to have z equals 4x plus 4y minus 8. Now, in terms of doing this with vectors, I know that my normal vector will be 4, 4, negative 1. So what I need is 4, 4, negative 1 dot x minus 2, y minus 1, z minus 4. And of course, that has to be equal to 0. That will give me 4 times x minus 2 plus 4 times y minus 1 minus z minus 4 equals 0. So I'm going to have, 4x minus 8 plus 4y minus 4 minus z plus 4 equals 0. Those 4's go away. Bring the z over. And I'm going to have z equals 4x plus 4y minus 8, which is the exact same thing that I got up here. Now, notice something to kind of keep in mind here. You never know when it may come in handy. The vector that's given by fxi plus the partial with respect to, I shouldn't say fx, it's the partial of f with respect to xi plus the partial of f with respect to y j minus k. This vector will always be normal to the tangent plane at the point x naught, y naught, z naught. So that means the tangent plane that touches this point. This little guy could come in handy every now and then.